Hello, this is a recording for the general discussion about experiment 5 which is on rotation. So, ang objectives ng experiment na ito ay i-verify ang conservation of energy and angular momentum for some system of disks. So, ang relevant parameters na ikakalculate dito ay torque, kinetic energy, angular momentum, and work done by friction. So, lahat ng concepts na ito ay covered naman sa manual mismo, pero you can also opt to watch the optional supplementary lecture that I have provided. It's also uploaded on YouTube, by the way. So, in this experiment, you will verify the conservation of energy and angular momentum for a disk rotating about its central axis. So, again, calculations ang main na gagawin ninyo dito for a perfectly inelastic collision din. So, let's define the formulas that you will be using in this experiment. So, you have your torque here, which is the tendency of a force to induce rotational motion on an object about some axis. So it can be defined as tau is equal to R, the cross product of F. So yung R mo is measured with respect to the rotational axis. So ang rotational axis ay simply ang point kung saan hindi gumagalaw kahit may umiikot. So normally, ito ay ang pinakagitna. For example, sa gulong, ganun. The axis isn't actually moving. So, the net torque experienced by an object will cause an angular acceleration, and it can be written as this formula here, which is actually Newton's second law for rotations. Ang alpha dito ay ang angular acceleration or how much the object accelerates as it rotates. So yung I naman is the moment of inertia about the axis of rotation. The moment of inertia is the tendency of a object to resist rotational motion. It's the rotational analog to mass. So, ang moment of inertia ng isang spinning object ay dependent upon its shape. Since we are using a disk here, ito lang ang kailangan nating alalahanin na formula. I disk is equal to 1/2 m, the mass of the disk, times the sum of the squares of its inner and outer radius. So, kapag mag-drawing ka dito, ayan, let's zoom in for a little bit. You have here a disk. So, meron siyang inner radius, itong distance na ito. At meron siyang outer radius, which is yung distance na ito. So, going back, now let us go to the conservation of energy. So, as you recall from your Physics 71, the total energy of a system is the sum of its mechanical energy and the internal energy. In Physics 71, we are only concerned with the mechanical energy. It's simply the sum of your kinetic and potential energy terms. So this is yung K1 plus U1 is equal to K2 plus U2 found in your lecture slides. So when your object is rotating, ang kinetic energy term natin actually will no longer apply yung 1/2 mv squared. In fact, ngayon, gagamitin natin dapat ay 1/2 I omega squared. So kaya ganito yan. This is the delta E change in mechanical energy is equal to the change in mechanical energy is equal to the change in the rotational kinetic energies of your object. I can write here this is 1/2 I omega So this formula is simply K1 minus K2 or Kf minus Ki, kasi you can actually expand this to 1/2 I disk times omega F squared minus 1/2 I omega I squared. So 1/2 I omega squared pala ito. So now let's move on to the work done by friction. So the work increases the total internal energy of your system. This is a factor that can be a reason kung bakit hindi masusunod ang conservation of energy principle. The work done by friction is normally found in a inelastic type of collision, whether perfect or hindi. So the manual already defines how to calculate this as your torque times your change in angle. It's negative kasi it represents a loss in energy. Pero for the purposes of this experiment, pwedeng i-ignore muna ito. So the change in total energy is simply the change in mechanical energy minus the work done due to friction. So next, we move on to the perfectly inelastic collision of your disks. So sa experiment dito ay isang case na gagawin ay may magpaparotate ng disk and at the same time may ipapatong na isa pang disk doon sa taas no already rotating disk. So the total angular momentum, if dalawa na to, so sa drawing na to pinagpatong yung dalawang disk na umiikot, the total angular momentum is simply defined as the sum of the I omegas. So this is I1 omega 1 plus I2 omega 2 is equal to your final angular momentum if it's conserved, which it is. So when a net torque is applied for a time interval, the rotational impulse experienced by the system is given by this formula here. And lastly, the rotational angular momentum impulse theorem states that this impulse J is just equal to the changes in the angular momentum. So, yung materials natin dito, of course, din yun naman ulit gagawin yung experiment. So, let's just discuss briefly about how these experiments will be conducted. Okay, so maraming section itong experiment proper. So, may mga supplementary videos actually na makakatulong to visualize what is happening. So, we have a set of videos here. Let's wrote disk intro. Teka lang. It's this one. Let's zoom in. So those are your 3 disks. The experiment would have been done by measuring the masses of each disks and recording them in the first table. So, calculate din yung moment of inertia using the masses and radii of these disks. The dimensions and masses of the disks are already provided in the datasheet. So disk 2 is not used here. So next, we have their conservation of energy principle. So the supplemental material here is rotation spinning disk. So ito. Teka lang. Let me just minimize. So your disk is already mounted here and it will be moving because of this machine here. So yun, pinatong lang talaga yung disk. Tapos pinapaikot siya. Okay. So we don't need your data collection steps here. So we'll complete table 3. Puro calculation ito. Data is already calculated for you. So very important. So yung change in mechanical energy, which is the work due to friction and the percent error. So lahat yung dalawa ito ay given sa taas. So you have here your change in mechanical energy, difference in kinetic energies ito, work due to friction. So tau, delta, lambda. Ignore the negative signs for this experiment. Magnitude lang kailangan natin. And we want the percent error. So the percent error is already defined by this formula here. Nandito na siya. So this is for table 4. So next, we verify the conservation of angular momentum. The supplemental material is rotation drop disc. This one, teka lang. Minimize. Kita niyo yung nangyari? Bumagal yung disc. Nung may pinatong na isa pa. So that's already a hint for the experiment. So yun. Again, we just, everything is recorded. The disk is already dropped. The angular velocities are already recorded. So what you will do is calculate the initial angular momentum, the final angular momentum using L is equal to I omega. You have your I and you have your omega here. Okay, let's write it here. L is equal to I omega. So you have you can use this formula here. So the percent error is given by this formula here again. So gamitin nyo lang ito to complete table 5. So addendum, these are just additional information that you don't really need to do the experiment. So this is the actual data sheet. So kung mapapansin niyo, wala ito. So walang kayo gagawin dyan. The inner radius, outer radius, and mass are given for 2 disks. So all you have to do is calculate the moment of inertia. Ops, isama ninyo ang moment of inertia, uncertainty din niyo dito. For this experiment, I just did the relative uncertainty. Note the units. So naka-cm ito, cm, tsaka ito naka-grams. Pero ang kailangan ng moment of inertia ay kg times square meters. So you also have to convert your measurements beforehand. So next, you have data of angles times angular velocities, final and initial. You use that data in table 2 to calculate table 3. So para mabilis, ano lang naman, so delta omega is just simply, hirap mag-type. Wait, I'll transfer to Word. Okay, so syempre delta omega is equal to syempre omega f minus omega I. So you have your delta t, then you have your alpha if you recall. So sa lecture slides ninyo, delta omega over delta t. Your tau is equal to I alpha. So yan, yung mga formulas na relevant that are either here on the manual or at your lecture slides. So, data for verification of conservation of energy. So, ngayon, you have your Ki. So, this is, again, rotational motion ito. So, I, omega I squared. Similarly, your final kinetic energy is ganitong formula rin. So, you have here trial 1, 2, 3 kasi meron tayong trial 1, 2, 3 na basis for tables 3 and 4. So, note nyo na lang na the labels tells us that this is for disk 1. So, yung table 4 data naman ay, ang table 4 ay also for disk 1 only. So, meron tayong data dito, Ki and Kf. Pwede niyo kuhanin ng I na kinalculate niyo dito. Just the central value is needed. And you have, you can calculate here your Wf and Wi. Diba? So, pwede mong makuha yan. So again, you can calculate your delta E, W, and percent error through your formulas given along in the manual. So lastly, you have your verification of conservation of angular momentum. Ito naman, you have your IA and IB. You have actually yung disk 1 and disk 2 na ito, or disk 3 pala, sorry. So ilalagay nyo lang dito yung moment of inertia nila na nakalculate nyo earlier. So you have here your L, your angular momentum, again, which is just simply equal to I omega. So you have your L, I, LF. Parehas lang lalagay nyo dito sa trial 1, 2, 3. They have the same moment of inertias. Yung sagot nyo lang dito sa table 1 ang ilalagay nyo for each column. So your percent error is also given earlier in the manual. I think, which one is it? This one, ayun, nandito lang naman. So, gamitin nyo lang yung formula na yan to calculate the percent error. So, lastly, dun sa questions, I'm going to give hints na lang sa bawat question kung paano nyo sasagutin ito. So, add text. Okay. So, for question 1, this is a perfectly inelastic collision. Again, this is a situation where colliding objects stick together and move with the same angular or linear velocity. So some references you can use here are your lecture slides. So in particular, para di kayo mahirapan maghanap, yung concept of perfectly inelastic collisions ay pwedeng makita sa lecture 18, while angular momentum can be determined sa lecture 24. So next is the total energy of the disk conserved in the experiment. So, conserved nga ba? Makikita mo naman dyan sa delta E nyo. Depends on your delta E. Change in energy. So of course, sagutin nyo rin kung bakit. Bakit siya conserved or hindi. So in the collision of disks, the system is not isolated because of the existence of friction. How is it possible that conservation of angular momentum is still valid? So to answer this question, you might find it good to use this guide question here. What is the effect of friction? And just how much and just how relevant is its effect based on our data? Malaki ba yung epekto ng friction based sa discrepancy ng ating change in energies or hindi? So sa last question, in most cases, this tree will not be concentric with the other disks after it is dropped. Will the final speed of this configuration be greater than or less than the speed in the theoretical scenario? explain. So here we can use the parallel axis theorem, which is found at lecture 21, energy in rotation. So that's it. Good luck with the experiment. You can do this experiment at any time before the stated deadline. Please don't do this over the reading break. So good luck to everybody, and thank you for listening.